Look at this. Why people are angry over Go's 1.23 iterators. By the way, I was very excited about Go's iterators. I'm very, very excited about it. And Ginger Bill is awesome. By the way, Ginger Bill is going to be on the stream here shortly. But I'm very, very, very excited about iterators. For those that don't know, what makes this great is that if you're programming some Go, which you do from time to time, you'll be able to do something like this. If I were to go to main.go here, we'll just pick any of them. I will be able to have some custom struct, and I'll be able to go for my custom struct and do like value or k value in range, my struct, which is super cool. Like that's a really nice feature. We're getting good features. Like Go is officially becoming a 2016's language, which is a good year. Okay, it's a good year. So I'm very, very excited. I looked at him yesterday. It looks great to me. I'm not sure what the problem is. Yeah, I actually want to see this problem. So I'm actually very excited about this. By the way, I did lose my voice at OpenSauce, so forgive me. Hey, forgive me, please. It's hard to talk. I can't scream today. We can't get into things. I want to get into things, but I can't. Because if I do, I'm going to lose my voice even more. Oh, I thought my sound was low. No. Yeah, Ginger Bill's very, very smart. No, this is based on, but completely rewritten from a Twitter post right here. Okay, so we'll open that up and look at that. TLDR, it makes Go feel too functional rather than being an unabashed imperative language. Isn't Go a fairly functional language to begin with? You have first-class functional support or first-class functions. We'll see. I saw a post. Let's see. I recently saw a post on Twitter showing the upcoming Go iterator design for Go 1.23, August 2024. From what I can gather, many people seem to dislike this design. I wanted to give my thoughts on it as a language designer. So, Bill, by the way, Ginger Bill is a language designer and a good one. The merge PR for the proposal could be found here. It has an in-depth explanation of the design explaining why certain approaches were chosen instead. So I do recommend reading it if you are familiar with Go. Okay, here's the example from the original tweet. All right, so backward. Takes in an any. We have this as an array of these any's. Functional, it's a that returns a function that takes in an int and an e and returns a bool. Then you return function, yield func, bool, for I, this one, and yield it out. Okay. This is where cleanup goes. Okay. We have this, and we can range backwards on S. There you go. See, we can range backwards on S, which is pretty cool, right? Like this is pretty cool. I immediately agree that there's a lot of effing syntax there to explain this. Yeah, curring. Yeah, we got some curring going on. This is a lot of effing syntax right here just to say something. Still easier to read than Rust? Potentially. This example is clear enough in what it does, but the entire design of it is a bit crazy to me for the general majority use case. From what I understand, it appears that the code will be transformed into something as the following. Backward, S, function, int, L, string, bool, format, this one, return true. Return false would be the equivalent of an explicit break. Okay. This means that Go's iterators are much closer to what some languages have with the for each method. Yeah, .for each in JavaScript and passing a callback to it. And fun fact, this approach is already possible in Go before 1.23, but it does not have syntactic sugar to use with the for range statement. Yeah, I'll try to summarize the rationale for Go 1.23 iterators, but it seems that they're wanting to minimize a few factors. Make the iterator look/act like a generator from other languages, thus the yield. Minimize the need for sharing too many stack frames. Allow for cleanup with defer. Reduce data being stored outside the control flow. I do like the allowing for cleanup with defer. I think this was pretty nice. At least I like that idea. As Russ Cox explains the original proposal, not regarding push versus pull iterator types, the vast majority of the time, push iterators are more convenient to implement and to use because setup and teardown can be done around yield calls rather than having to implement those as separate operations and expose them to the caller. Direct use, including with range loop, of a push iterator requires giving up storing any data in control flow. So individual clients may occasionally want to pull or want a pull iterator instead. Any such code can trivially call pull and defer stop. I generally prefer pull over push. Like generally speaking, I think pull over push is the way to go. And why I think it's the way to go is that you can create really beautiful like lazy items, which makes it really, really nice. As opposed to like kind of push, it's like you have to create like these buffer zones and all that for it. And then you kind of have to do a lot of you have to do, like, often copies are involved when you do that. So, like, JavaScript would be a push. When you do a dot map, it executes the entire array across that dot map. Whereas when you do a pull, it grabs the first value, it goes through the map, it would then go through the iterator or the filter, and then come out, say, the for each. Whereas with JavaScript, it does the map, it does the filter, and then it does the for each. which is that's the difference between push and pull. So I generally prefer pull over push. I think it just makes it nicer in general. It just also makes it really easy to understand. All right, Russ Cox goes into more detail in the article Storing Data in Control Flow and about why he likes this approach to design. More complex example. Do not worry about what it actually does. I just want to show you something of the cleanup needed for something like defer. Okay, an example from the original PR shows a much more complex approach requiring cleanup where the values are pulled directly. All right, let's see. So we are doing just a value-only iterator, and it's a sequence V, and we're going to return a sequence of 2 Vs. Pair returns an iterator over successive pairs of values from sequence. All right, we're going to pull, stop, 1, 2. If not 1, 2, yield this one. There we go. Okay, I think I get this. I know you said not to worry, but yeah, you just take 2, you just create pairs over it. Okay, an alternative, a pseudocode proposal, state machine. I'm not suggesting Go does this whatsoever. When designing Odin, I wanted the ability for a user to design their own kind of iterators, but have them be very simple. In fact, just normal procedures. I didn't want to add a special construct to the language just for this. This would complicate the language too much, which is what I wanted to minimize with Odin. One possible pseudo proposal I could give for Go iterators would look something as the following. Backward on any array function int bool, this one, return function on break int this one, if on break, or I is greater than this one, this is where cleanup goes. Else, we do this one, we return it out, return it. Oh, I think I see what's happening here. We're just assigning these values. Oh, naked return. Yes, these are just naked returns, right? Do a little naked return on here. We get index, elim, and OK, and then just return it. I know, I'm not a naked return guy. Ginger Bill, dirty man. Dirty man with that one. This pseudo proposal would operate like this. Yeah. Okay, generally like it. This is from what this is similar to what I do in Odin, but Odin does not support stack frame scope capture closures, only non-scope capturing procedure literals. Because Go is garbage collected, I see little need to not utilize them like this. The main difference is that Odin does not try to unify the idea into one construct. I know some people will think this approach is a lot more complicated. It is doing the opposite of what Cox prefers, with storing data in control flow and stores the data outside of it. But this is usually what I want from an iterator rather than what Go is going to do. This is the problem. It removes the elegance of storing the data in the control flow, the push-pull distinction that Cox explains. Yeah, so I assume what he's trying to say is that notice that you have to store the data here, and you use that as control flow as opposed to having it right here, which is like you don't store it outside of the function. You actually store it right here in the you store it right here in the actual this one, and then you iterate over it. And so it makes like just a small difference. But I mean, this is probably a bit closer to what Rust does. Rust, you typically have a struct that is your iterator, that implements iterator, in which contains these items. And then every time you call it, it's able to operate over that. An iterator having a state tracking where it's at doesn't sound bad. Yeah, see, I don't think it sounds bad. For me, it's very, very simple to implement that. I know, I understand it much easier that way. At least it's very easy to implement in my head. I am very much an imperative programmer, and I like how things actually execute rather than trying to make elegant looking code. So the approach I wrote above is fundamentally about thinking with regards to execution. I don't know what NB is. NB, the type class interface route would not work in Go because this would not be an orthogonal design concept and actually be more confusing than necessary. This is why I didn't originally propose it. Different languages have different requirements as to what works with them. Go's apparent philosophy. The approach in Go 1.23 seems to go in the face of the apparent philosophy of making Go for the general, frankly, mediocre programmer. Okay. You know, like, I like Go. Bro, can we just take a second here? Hey, can we just take a second here? Yo, I'm officially a mediocre programmer at Google. Let's go! Let's go! Oh, baby. Oh, baby. Oh, baby. Let's go! Karen, get out the champagne. It is official. I am mediocre. I mean, that's a huge upgrade. Did you see what Google originally said? Not good. It's not looking good, but now it's looking great. Literally better than Ken Thompson. Inventor of C, can't commit to C. Me, boom, middle of the pack, putting down W's left and right. Can I get a pay raise? I wish I could be mediocre. I know one day you're going to be mediocre, Shaun of the Dev. Not there yet. You're not there yet, but one day you will be. Mediocre, is that an upgrade from Quiche Eater? Yes. Yes, it is. Absolutely mid. We're definitely, I'm going to just take that and we're going to tweak this. This feels like a great thing. Ginger Bill, I'm finally a mid programmer. I love it. I love it. Oh, I'm so happy right now. This is such a good article. It's not elitism, by the way. For those that don't understand, Go is designed so that anybody can be successful. Like, you don't have to be smart to use Go, okay? And what I mean by that is try Zig for a moment and realize that there's programming languages in which you need to think about everything, and there's programming languages in which you can be very productive in. Like, I'm getting good at Zig. I'm actually getting what I would consider to be pretty dang good at Zig. But that doesn't mean it's easy. Like, I'm building things, I'm able to do stuff. I feel pretty fast at it now. I know how to make interfaces, vtables, all that kind of stuff. But I'm not fast like I am with Go, right? Go is just like, you don't even have to think. You just don't. You just build it. And when you don't like something, it's pretty easy to patch over what you've goofed up and then add on top of it. And when you don't want to do that anymore and you want to fix it, it's pretty easy to fix and refactor and move on. Grug want mid? Yeah, I'm a real mid. I'm a mid man. I'm a mid man. Go is the fluffer language for mediocre devs. Yeah, I like it. That's why I love Ruby. It's so fast and easy to make everyone so productive. Yeah, I mean, I never discount the productivity argument, generally speaking. I think that when people say that you use a language in which is really productive, I agree. But if you say that about JavaScript, I just disagree with you. As a person that's probably better than you at JavaScript by a country mile, like by a long country mile, by a New York block. It is a very hard language to be good at and to write well. And I know people think that it's easy. That's what makes it so insidious. Anyways, hello Prime. Well, hey, nice. Look at all those little yar hearts. Anyways, the quote Rob Pike. The key point here is our programmers are Googlers. They are not researchers. They typically fairly young, fresh out of school, probably learned Java, maybe some C or C++, probably learned Python. They're not capable of understanding a brilliant language. Well, okay, well, I really always hate these kind of things. When someone says they're not capable, I'd say the job that they're doing does not require, right? Big difference. Big difference. Thank you for all the booty. Thank you for all the dumpy, baby. Right? I know it's very elitist. A brilliant language, but we want them to but we want to use them to build good software. So the language that we give them has to be easy to understand and easy to adopt. Yeah, I mean, Go is very easy to understand and very easy to adopt. It's, in fact, as somebody who only gave Go a real shot this year, like a real shot, built a really hard program in Go, I was shocked at how nice the experience was, because the types are so simple, I thought I was going to hate it. Like I did. I genuinely thought I was going to hate it, but I'm fine eating kale, eating a mid-language, doing a mid-language because I'm like, whatever, it's going to be, I want to give it a shot, But now that I've done it, I realize the beauty in the grug nature of it all. C is easy to understand. Now try building something complex with it. Yeah. I know many people are offended by this comment, but it's brilliant language design by understanding who you are designing the language for. It is not insulting, but rather the matter-of-fact statement, as Go was originally for people who worked at Google and similar industries. And funny part is that old Google 10 years ago, they were known for hiring pretty smart people. You might be a better and more capable programmer than the average Googler, but that doesn't matter. There's a reason people love Go. It's simple, opinionated, and most people can pick it up very quickly. Yes. However, this iterator design seems out of character to Go, especially for someone like proposer Russ Cox, assuming that he was actually the original proposer on the Go team. It makes Go a lot more complicated and even more magical too. I understand how iterator system works because I'm literally a language design and compile implementer. It also has the possible issue to it won't be a well-performing approach either because of the need for closures and callbacks. Yeah. I'm very curious about the closure and callback thing because that is typically not a very good performance. I learned Go before I learned HTMX. Damn, really? Is it called Go from Google? Probably. I mean, can we be real here? I know it's called Golang, but I assume it's just Googlelang. Maybe the argument for its design is that the average Go programmer is not meant to implement iterators, but just use them, and that the majority of iterators that people will need will already be available in Go's standard library or by third-party package itself. So the onus is put on the package writer and not the package user. Fair. I think that's pretty fair. I mean, the thing I do like about it, it's going to unlock a lot of cool behavior. And so they already put in generics. They already have this like generic slice package and maps package, which is super nice. And now they have this. So I am happy in the direction of Go. Like I am. I'm very happy in the direction of Go. And I hope they keep making really good direction changes like this. I think they're just realizing that you can't make a language so simple that people need to rewrite everything every time. You need to make a language simple enough that everything you need to write should already be written and provided in the standard library, right? I think that's like a pretty good approach, and that's largely what they've done. Lua is a very simple language, but it's actually a really powerful language. It's really easy to write well. This is why I think a lot of people seem to be angry over the design. It goes against everything Go was originally meant to be in the eyes of a lot of people, and it seems like a really complicated mess. I understand the beauty that it looks like a generator with the yield and the inline code approach, but I do not think that is necessary in the vein of what Go is to a lot of people. I actually wish they would have gone much more the Rust route, honestly. Have some sort of iterator function interface that you could implement, and then you can just range over it, right? If you provided a next and is done or whatever, whatever way you want to do it because they don't have optionals. I mean, personally, I think that would have been fantastic. I mean, I know it could have collided with other things and maybe you had your own iterators that had something similar. And maybe that's why they're kind of avoiding it is by having this really complicated way. You can do a functional way to do it. I think doing an interface would have been so much nicer. Just like string, right? If you do formatting, you can just have string. And if you implement string, it just works in the formatting, which is really, really nice. Go does hide a lot of how the magic works under the scenes, especially when garbage collection, Go routines, select statements, and many other constructs. However, I think is a little too magical in that it exposes the magic to the user a little too much, whilst looking overly complex for the average Go programmer. I do think that this, like, generally speaking, the yield side of things, like I honestly don't even know what it's doing. I'd have to go read about how this works because yield usually is like a replacement for return, but it's like now a function, but you have yield func. This must be the name of the function called yield. Maybe you can call it anything. I assume I've never seen what's called named functions this way. So that's what I assume it is this just simply means, hey, it's time to be done. Maybe, I'm not really sure. Or you yield out the value to the loop. Yeah, that must be what it is. This yields out the value out to the loop, right? The word yield kind of tricks me here. This is, yeah, okay. So this must be the one that's doing it. Okay, I see it. It just feels complicated, right? Yield is the loop body, basically. Yeah, it just feels complicated for me because my brain had to at least the examples, my brain has to stop using yield in the word or in the way I'd normally use the word yield and use it different. Yeah, they should have called it yeet or loop body or loop brain. What's that? I don't think I have one of those. You probably don't. Did you ever see that? This is why it's confusing to me. Yeah, that's why I got so confused at first. Now I understand it. This makes perfect sense, right? This is literally just the function. You're just calling the function. If that function returns false, you return false, which is kind of a generally interesting thing. I wonder how this works with breaking out of. You know what I mean? Like, can you do something like this? Let's go back to the Go. I wonder if you can do something like do something with like outer and break outer. However that looks, like just sounds confusing, right? I assume that's it just all works, but still it feels confusing. You know what I mean? Yeah, it has a go-to effectively. Yeah, it has a go-to because you have to break on the inside and the outside. So, okay, you can. Okay, isn't that a go-to? That is, oh, boys, that's a go-to. Hell yeah, go-to considered amazing, and you can screw off. All right, here we go. Maybe the argument is for the, oh yeah, we already read that. The other aspect where people find it confusing is that that returns func that takes a func as an argument, and that the body of the for range is transformed into a func, and all breaks and other escape control flows are converted into return false. It's just 3 levels of procedural deep, which again feels like functional language design rather than imperative language design. Okay, no, I'm not suggesting they replace the iterator design. What I am suggesting, but rather a generalized iterator approach may not have been a good thing Go in the first place. Oh, really? For me, at least, Go is an unapologetically imperative language with first-class CSP-like constructs. It's not trying to be a functional-like language. Iterators are in the weird place where they do exist in imperative languages, but they are very functionally, but are very functionally as a concept. Iterators can be elegant in functional languages, but in many unabashed imperative languages, they always feel weird, somehow because they are being unified into a separate construct rather than separating out the parts of it. I could buy this. Initialize, iterator, destroy. Yeah, this is yes. Okay. I really do like this. Go relies heavily on closures. Fine, it does rely heavy on closures, but it is a very imperative language. Typically, if you're using a lot of closures, I would be a bit surprised. And what I mean by that is that means the only thing I can really argue in my head for a lot of closures, that statement, is that you must be doing a lot of go func, make a request that's outside the loop in a wait group and then or an error group and then get all your responses back and call it a day. That's at least how cuz like the thing I built with a bunch of byte processing and compression and all that, there's no closures. Right? Closures just don't really happen in non-highly parallel slash whatever the other word is. I don't know why I'm blanking on it. Concurrent programming. Recently, I heard about lambda calculus. Oh gosh, here it goes. Here we go again. What's an imperative language? I go A, then I go B, then I go C, then I go D, then I go E. Right? Yeah. Let's see. Aside, Odin's approach, as I alluded. Sorry, my voice is still a little bit lost, so please forgive me. Then I go P. Then I go a lot of PP. Yeah. No effing around here. Aside, Odin's approach, as I alluded to previously, an iterator is just a procedural call where the last value of the multiple return is just a Boolean indicating whether to continue or not. And because Odin does not support closures, the equivalent go backward iterator in Odin is a little more code to type. Note, before people say that looks even more complex, please continue reading the article. Most Odin iterators are not like this. I would never recommend writing such an iterator where a trivial for loop is preferred for both the reader and the writer. All right, backward iterator. See, I like this approach already, which is this right here. I liked the struct. This is a very, Rust does this too. Having a struct for the iterator. I like this approach. Backward. Get the procedure, you get the backward iterator, you give it a slice, it gives you backward iterator. It starts right here. See, the state's stored on the struct. I prefer this by far. Like, absolutely. There we go. This makes 10 times more sense to me. It just does. If this is greater than this, we do this, else return. Yeah. Naked returns, I hate it. There we go. This is beautiful. To me, this actually looks much simpler than the Go one. I know, like, to me, if we go back up to the top, if I compare these two things, like, I find this, I'm just going to go like that. If we're going to be real, even though this one is much more, shall we say, concise, I find it to be way simpler to understand. Right? Like, this is much more concise. You can see it in a small screen, but the amount of funcs that you're trying to funk yourself with is very, right? It's a function that returns a function that takes in a function that returns Boolean, right? Whereas this one, it's just like, I have my struct. This is very one-dimensional, I understand. I can make one by just simply doing that. I can iterate very easily by saying, am I greater than or equal to 0? Awesome, do that. Else, return. Like, this is just extremely simple code. There's no one has a question about how it works, despite me. I have no idea what any of this, like, I don't understand this syntax at all, but this is so simple to follow. I'm shocked that Go did not do it this way. It just feels better to me. Right? It just feels better, Let's see, I'm a funk, playing a funk. I'm a funk that's playing a funk disguised as another funk. Oh my gosh. Dude, you literally just accidentally made a great meme. We're going for it. Let's go. What is it? Tropic Thunder memes generator. Let's see what we got. Yeah, generate that one. Save the image. Go to Twitter. Go 1.23. Boom. MIT license. Bam. I'm a funk playing a funk disguised as another funk. Dude, that is so good. Thank you. Thank you for your service. Memes is speed running a meme. Quick speed run of a meme. Pleasure to be of service. T.S. Clay, you're a beautiful man. Great movie. Too many funks given. Just so many. Anyways, all right, let's go back to this. By the way, I'm shocked that Google didn't do this or Go didn't do this. I still am shocked. I honestly, in my head, this is actually also, by the way, just to be fair, this is also how async iterators work in JavaScript, because it's the only sensible way to make async iterators. Hey, Ginger Bill, I was just letting you know, hey, look, it's the writer of the article. Ginger, I was just defending you, saying that, like, this is the only sane way to make iterators, I think. I don't understand why you wouldn't require a struct that implements an interface, and that's that, right? Because that actually feels very Go-y. If you think about it, like, Go always offers ways for you to implement. If you want a reader, it's just a struct that implements an interface. You want a writer, it's just a struct that implements an interface. You want something that can be stringified, you implement the string interface. So it's like, it's shocking that it didn't just follow all the other things. Now, the difference is the state machine versus struct. Yeah, I know. And I hate this argument because a struct state machine is the only, in my personal opinion, is the only sensible way to make an iterator. This feels very confusing to me, right? This feels confusing, just generally speaking, because I don't want to be a funk that's disguised as a funk that is a funk anyway, or I'm a funk that is a funk that's disguised as a funk. It does not shock me why they didn't make it an iterator, because it doesn't actually work, because the iterator in Go would have to be extremely generic. Okay. Yeah. Okay. Fair and factual. I can understand that argument for it. A lot of funking going on. Yeah. All right. Anyways, this does not appear to be more complicated than the Go approach, because, this does appear to be a lot more complicated. I'd actually fully disagree. This appears to be extremely one-dimensional, and a baboon such as myself, a grug brain dev, this makes perfect sense. I get it. This is what I would say does not require 200 IQ. This is what I think requires 200 guy IQ. Honestly, I do think it's more complicated than the Go approach, because it requires you to write a lot more code. However, just use Copilot. Just use Copilot. Boilerplate mentioned. However, it's actually a hell of a lot simpler to understand, comprehend, and even faster to execute. The iterator does not call for loop's body. Rather, the body calls the iterator. I know Cox loves the ability to store data in control flow, and I do agree it is nice, but does not fit well with Odin, especially with the lack of closures, because Odin is a manually memory managed language. An iterator is just syntax sugar for the following. Yeah, that's literally all it is. That's why in Zig right now, when you look at Zig, I created for the game, I created an FPS iterator, right? I can't just like call, hey, for range on my iterator or on my FPS iterator, but it does actually work really, really nicely to be able to have something that I can be like, hey, sleep the appropriate amount, give me the delta, and then the next time it's called, depending on how long my game loop took, it can then sleep for the appropriate amount of time. It's a very simple kind of iterator-ish type pattern. Odin catches my eye lately. Yeah, Odin's a very interesting language. Odin's approach is just removing the magic and making it extremely clear what's going on. Construction and destruction must be handled manually with explicit procedures. And that iteration is just a simple procedure which is called each loop. All three constructs are handled separately rather than managed into one confusing thing like Go. Yes. I do agree that the follow-up agreeing is that the cleanup code will make it much more confusing looking. Because if you have any level of cleanup code that's more than one line, there's just like a lot that goes on right here. All right. Odin does not hide magic, whilst Go approach is actually very magical. Odin makes you handle the closure-like values manually along with construction and destruction of the iterator itself. Odin's approach also trivially allows you to have as many multiple return values as you wanted to. A good example of Odin's core encoding CSV package, where the reader can be treated like an iterator. By the way, fun fact for those that are wondering, CSV does not have an official standard. There is a RFC, but there is no official encoding of a CSV. How effed is that? How effed is that? CSV is a god awful standard. Yeah, I know. How like screwed is that there's like a thing that people use all the time that actually doesn't have a standard. Have you ever used it where we've had some CSVs produced when I was at Netflix, dumping data from our big data into records worked with like half of the CSV parsers. The RFC for CSV had an extra comma in it, so it couldn't be read in Excel. Isn't that just so good? Isn't CSV just such a funny thing that we deal with? It's actually literally the world's worst format, and yet there it is. Drink some water, prime. No, I lost my voice. Microsoft Excel CSVs do this shit for non-ANSI characters. Damn, dude, it's just so effed up. Encoding procedure, reader, string, index, error, more, bool. Okay, nice. Aside, C++ iterators. I will try not to get into a huge rant about C++ iterators in this article. Everything C++ did for iterators. C++ is the only language in which asks me, would you like me to install Copilot? And for me to say yes. C++ iterators are much more than a mere iterators, whilst at least Go's approach is a mere iterator. I completely understand why C++ iterators do what they do, but 99% of the time I just want a mere iterator, not something that has all the algebraic properties that that allow it to be utilized in more general places. Dude, everything with C++ iterators felt very hard. They feel extremely difficult. Lost your voice at a redneck lawnmower trailer pull competition? They like unironically, a redneck lawnmower trailer pull competition is exactly something that OpenSauce would have. For people who don't know C++ very well, an iterator is a custom struct class which requirements is to have the overload operators to make it act like pointers. Historically, a C++ iterator would look like this. Isn't that just lovely? Don't you love a good old-fashioned begin not equal end begin plus plus? Look at that beauty. Ain't nothing like it. You got to throw in a little const in there, a little const auto reference. Mwah. Dude, I hate them. And would be wrapped in a macro before C++ 11 range loops. Yeah, the big classic thing to do is you make a for each macro, and then you use that to do your actual iteration. Before C++ arranged a for loop syntax and auto became a thing. The biggest issue with C++ iterators require you to define 5 different operations at a minimum. The following 3 operation overloads: equals, does not equal, plus plus, pointer, along with 2 standalone procedures or bound methods which return an iterator value, begin and end. If I was to design a C++ mirror iterators, it would have to be as simple as a struct class that calls an iterator next or something, and that's it. Yes, it does mean that the other algebraic properties are lost, but I honestly do not need these ever for any problem I am working on. When I'm working on those kind of problems, or those kinds of problems, they always be either a contiguous array or I implement the algorithm manually because I want to guarantee the performance will be good for the data structure. However, there is a reason I made my own language, Odin, because I completely disagree with the entire C++ philosophy, and I want to get away from that madness. Does anybody know what language inspired C++? Anybody? We've had a couple people know it. Simula. What is that? Nigar, right? It's Nigar and gosh, I can't remember. Anyways, Simula called it. Very great story, by the way, how Simula was created. Very cool story. Very, 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 very cool story. It's actually Simula both was born and died on the fact that it was a simulation language trying to be a general programming language. It's kind of sad. It's kind of sad. Hey, thank you very much, Gucci. Algo 68 supremacy. Yeah, so they compiled down to Algo, but eventually had to quit doing Algo due to a stack. One thing that was really cool about Simula is that there was no such thing as this idea of storing data on the stack and coming up Dal. That's right, Dal. Yeah, Nygaard and Dal. And coming up with this idea of storing a bunch of stuff on the stack was like extremely, first off, is considered distasteful, gross. But second off, it just like wasn't really done. And they like came up with it. Pretty cool. It's super cool. Like a genuinely super cool like story. C++ iterators are a hell of a lot more complicated than Go's iterators, but they're much more direct with the local operation. At least with Go, you don't need to construct a type with 5 different properties. In conclusion, I feel like Go's iterators do make sense with the design principles, but to them, applied to them, but seem antithetical to what most people view Go as being. I know Go has had to get more complex over the years, especially with the introduction of generics, which I do think are actually well designed with only a few syntax quibbles. Yeah, I mean everybody still. But the problem is everybody wants one thing to really make generics awesome, which is method receivers. But it does appear that you can get around some of that because I know there's some generic libraries in which I don't even understand how they work, but they do work. But the introduction of iterators of this ilk feels wrong. I think the short of it is that it feels like it goes against the apparent philosophy of Go that many people believe, coupled with being very functional way of doing things rather than imperative. And because of those reasons, I think that is why people don't like the iterator stuff, even if I completely understand the design choices made. It doesn't feel like what Go originally was to many people. Maybe the concerns of mine and others are overblown and most people will never actually implement them and just use them, and that them being this overcomplicated to implement. Second to last controversial take. Maybe Go needed to gatekeep even more than just tell the functional bros to go away and stop asking for such features, which make Go a much more complicated and complex language. Last controversial take. By the way, I do like this. You should. This is, I mean, I'm sure Ginger Bill will 100% say this, that his language likely has a bunch of people asking for things that he has to say no to constantly. And that there's an entire collection of people that want Odin to probably look like Rust, or look like Go, or look like Zig, or look like fill in the blank. And he has to say no a lot. I dislike Go iterators. There, I said it. I mean, I want to dislike them, but I also want to use them. I mean, that's where my big problem really comes down to, because I find myself doing dumb things. Now you say no a lot. Not surprising. Grug's favorite word is no. Yeah. What language is fill in the blank? It's a new language. You wouldn't understand. Here's an example of what I really want. If you look up, let's see. There you go. I have this idea of a virtual box, which is just a quad tree that you can replace and replace the underlying buffers for. And what I had to do is I had to do I created this whole next idea, and I had to create like my own iterators. So it's like it has these byte iterator results, which has this, and then like I had to do all these things. And when I want to use this, I have to do things like this. I have to like range over certain things in a very annoying way that I really hate because I can't just simply do it well. Right? Like, look at this. I have to for forever, get this, then I have to do that. So it's like, I want that because when I get the result and the result is done, I have to like manually break. I just want something that I can make a struct that I can walk with. You know what I mean? I like that. I like the next. I like the done. Make it easy. Anyways, I don't know. Go iterators feel really clever, which I think people feel is anti-Golang, which is another way of saying what Ginger Bill was saying. Yeah, that's probably fair. That's probably really fair. Yeah, but simultaneously, I read someone else's code and say, I hate this. Yeah, I think reading someone else's iterator code is going to be intensely more difficult, right? Intensely more difficult. I actually really agree with that. Reading, you, pick, careful now. Hey, Prime. Thor told me your deep dark secret. Your stash is green screen CGI on your face and not real. The name. The stash is actually real, buddy. Don't try that. Don't you? Thor's just angry because we got 1,000 people to sing him happy birthday. Again.